Okay, so let's take a look at how we define a class. So first I have to fix my spacing. Cool. And actually I'm ditch these. Okay. So I define a class with the keyword class, and then I can I give it a name. I'm gonna call my name person, or my class person for right now. And I always capitalize the names of my classes. And then once I have this, actually we can do, we're just gonna pass for right now. So I've created the class. This is kind of like when I create a function definition, right? If I define a function, it doesn't really do anything for me until I do what? Call the function. I need to call the function, right? I can write a bunch of definitions and run my program, and it'll read all those definitions and exit. But it doesn't do anything till I call it. So same kind of thing with a class, right? So when I initialize a class, it's going to give me back what's called an object. It's going to have a specific place in memory that it's saved, and I can hold on to that object just like any other data type. So just like a string, a dictionary, in a variable. So let's start with a variable, and we'll call it Josh, and we will do person, and then call it like we call a function. And then what I'm going to do down here is print Josh. Cool. So let's run this and see what we get. Cool. Yeah. So this is what an object looks like when we print it, basically, right? So it's going to give us the name of the object. It's going to tell us an object, and it's actually going to give us this big scary number, which is just its place in memory, where it is saved in memory, right? So now the advantage of this is I can do Juan. Did I spell that right? Yes. Person, and I can do Bobby. Person, right? And then, whoops. Cool. Print this. See, we get the same person object, but we get these different places in memory where it's saved, right? So right now, the only thing that's different between these things is where they're saved in memory. I've defined one class, and now I can create, these are called instances of the class, right? So we define one class, we create instances of it. The way I like to think about it is like, think about a factory, right, that makes cars. So someone designs the car, right? And I don't know anything about cars, but they probably do a bunch of complicated shit, and then they get these blueprints for the car, right? Then they give that to the factory. So then the factory starts to make some decisions as they make the cars. The cars are probably all the same in a lot of different ways, but they make a certain amount of red cars, make a certain amount of blue cars, and all of those cars coming out of the factory are instances of those blueprints, right? The blueprint is the definition, and then the actual cars that they're making, those are like, if we're talking about programming, instances of it, right? And they might have different colors. Some of them might have automatic locks, some of them might not. Some of them might be, I don't know, different things about cars, right? Does that kind of make sense? So, a little bit, getting there? Okay. Cool, so that's what we've done here with our class person. So now, how do we start to do, like, this isn't interesting at all, right? So how do we start to do more interesting things to it? So here we have all of these, let's just start with adding attributes, right? So I want to add attributes.
Can I give another example that might be easier?
Sure.
So if we all work at the same company, some of us might have admin rights and some of us might not. So it's a lot easier if you're writing like this person an admin or just a regular user. But if we're all at the same company, we're all going to have the same attributes.
Yeah.
Except for it's just
Yeah, so
Like the car scenario, where there's like a bunch of different-
totally. No. That I mean, that's another. So what we're saying here basically when I create a class is like I want to make a bunch of objects called person. I want all of those objects to have name, city, date of birth, and is alive. Like those need to be there. But I want the values for all of those things to be different, right? Because not everybody has the same name, city, date of birth, etc. Right? So this is where we're going with this, yeah. And not everybody has the same admin privileges. In fact, is alive is, I don't know why I think that's so funny, because is admin is probably something you would see more often, right? Or even just admin. So let's go with admin. What the hell? Okay. So when I create this instance of person, a couple of things happen, right, in the computer. It's saving it in a location in memory. If I have any methods attached to it or any attributes attached to it, it's going to save those. But also, right down here, let me move this up. When I'm calling person, what you can really think of in your head is it's going to immediately call this special function that I just created called init. So there's this concept of, they call them Dunder functions in Python. And they're functions that have, it's because they have two underscores. So let me just type it one more time. So it's like underscore, underscore, init, underscore, underscore, right? These are protected functions. These are functions Python kind of like already knows what to do with. And they're just kind of to like namespace them or protect them. They're usually surrounded by these underscores. Cool. So init is one of them. When I'm inside a class, if I create this init function, Python knows, oh, I'm going to run that the second you create any instance of this class. I'm going to run this function, right? So right now, I'm going to actually like let's not do this. Right? Let's just say print hello. Okay. So I'm going to create 3 instances. So how many times are we going to see hello? 3 times, because it's going to run an init when it creates the person for Josh, for Juan, and for Bobby, right? Run that, and we're going to see hello 3 times. Does that make sense? It's going to run init every time I create a new instance of the object. So we use this more commonly to set what are called instance variables, right? Which are variables very much like in this dictionary that belong to that object. So the way we do that is we do self.name equals name. I'll go over this in more detail. Self.city equals city. Self.dob equals dob. And self.admin equals admin. Okay. You're gonna hit, if self is new to you, just prepare to be confused for a couple days, you'll get it. But who can try to explain what self is?
Yeah, you can do it. All right, you do it. Self is referring to this class, even though like self is something that like when you're doing, if you're creating like this class or whatever, and you want to refer to a function that was created in this class. You know what I mean? I feel like self will refer to that.
To the class?
Well, not to the
It's
class.
not to the class.
But, okay.
Try them up.
Yeah, give it a try.
So self is the one thing that your instance knows when it's created. So when you do self.name, you're creating a variable called name. And it's confusing that you're assigning it to name. Self.name is like, oh, I'm making a name and I'm setting it to the past parameter. You can actually name it something other than name. And assign that to the instance variable. And it exists as long as the instance exists. So if you make a person, self.name equals name, that name you gave it in the constructor will stick with that instance.
Let's hold on. Let's do this real quick, and then we'll see. Okay, this is a hard concept. Okay, let's pretend I created a class marker, right? And class marker takes in color. That's it. So init color and it's going to say self.color equals color, right? So I'm going to make one marker. There you go. Another instance of marker. another instance of marker, and another instance of marker, right? So I have class marker. Let's write this down. What do I need? A marker to do this. Class marker. Init. Self. And color. Self. Dot. Color. Equals. Cool. When I created that marker, I entered brown right there. When I created that marker, I entered, what is it, pink, blue, so on, right? Okay. So far, so good? We have all these different color markers. So now that I have these instances, I can ask these instances of classes, I can ask them questions. And so the way I do that is I can write a function that's like def color self return self dot color. So what we're trying to get at is, what is this self when I say self, right? So what I'm saying is, what is your color specific instance? So if I ask your marker, what color are you? You return what? Thank you. What color are you? What color are you? So I have this exact same method, right? This exact same method that returns self.color. When I say self, I mean you, the specific marker I just created, right? You, the specific car that just came out of the factory. Self means that instance. Question? Yes?
Don't you also just do whatever the instance name was, dot color in this example?
If I'm defining this in the class, what do you mean? Whatever the instance name
Yeah,
is?
so like say brown marker, you pass it brown, and it's constructed, initiated color to brown. Didn't you just do whatever the instance name you gave it?
Oh, yeah. But for the purposes of this, I just wanted to do this. But yes, we'll get to that. Well, the most important thing right here is I'm just trying to get at what does self mean. And for the brown marker, it means me, the brown marker. For the red marker, it means me, the red marker. Whenever I refer to self in my definition, it's like a placeholder for the individual instance. Yeah. Thank you.
I'll wait till it's like, let's say it's like the easy way to,
Go
I'm
ahead.
just gonna draw.
If you want to clarify it, clarify it.
Like for me, like when I think about it, it's basically just like this, right? Mm. JavaScript, it's like this.
Mm-hmm.
Like, okay. So this doesn't know what self is. This is just the blueprint, right? Until you call on the class, and then it knows that self refers to what called the class, right?
Yeah, actually, you know what? Let's pass these new variables some names and check those out.
Like give a name or something like that.
So let's do this. In fact, let's get rid of these because I think we're going a little too. Okay. So right now I'm just gonna have self.name, right? So here, actually, let's do this. And I don't want you to get confused because of these variable names, though. So let's say like Joshua. Is there a longer version of Juan? Okay. Juan is great. And Robert. Okay. So I've created a class person, and I've defined the function that will get run every single time I create an instance of this class. I have said it has to take in self. So every function needs to take in self. We'll get to that in a minute. And then I've said that it needs to take in name. I don't need to pass in self on my own. Self will get passed in for me. So the first thing that gets passed in is name. So I create a person, Josh, and I pass in a name, a value for name. I create a person, Juan, and I pass in a value. So now I come down here and I do dot name, and dot name. There's an object that's getting saved to the variable Josh. There's an this is confusing. Okay, that's a little bit better. Okay, so an object is getting saved to each one of these variables with specific names. And then what I'm going to do is I'm going to print that variable dot name, because I can access any of the attributes with this dot notation, kind of like in JavaScript, right? So now, if I print these, it's going to print different names for each one, right? Even though I called the exact same attribute. Question? So far, so good. So we can do other ones too. And these do not have to be, let's say, is admin, right? But then I can say self.admin equals is admin. So all I'm doing is just like any other function, I'm taking the parameter that's passed in and I'm assigning it to a variable, right? Self.variable. This doesn't have to be the same, like name and name don't have to be the same. So now I can do true, false, and false. Oops, a little too farther. Print.
Just not a space.
Can I do plus? Is that gonna work for
That's
me?
the error type. You just comma space person one dot name.
Like that?
Yeah.
Print will do this?
Yeah. Person dot or underscore one dot name dot admin. I love comma.
Do we understand these attributes? Are there any questions about how we're assigning these attributes? No? Cool. So there are instance variables. It's about to get a little bit more confusing. And we can get at those with stealth. So actually, let's just do one more thing. So we now what I can do is I can assign a bunch of functions to this class, and they'll be available on any instance of the class. So I can do def say hello, takes in self. All of my functions in my person class need to take, or in my class need to take in self. And I can say return, we can do like an F string, right? And we can say, hello, my name is self.name, right? Let's get rid of all of this.
Self is automatically passed, though, right?
No, it's not automatically passed. I have to put it in here.
Oh, I know that's
Right. What do you miss?
I have to pass it into the function.
Okay.
It won't belong to the class if you do it yourself.
And now down here, I'm going to say, actually, let me get those. And actually, let's just have it to make it easier. So now I'm going to do person1 dot say hello. So now this object has this function attached to it, right? And I can call it whenever I want. I can do same thing with person2 dot say hello. And I don't have to rewrite this function over and over again. I only have to define it once. Person3 dot say hello. Hello, my name is, but it's going to replace self.name with whatever name for that instance. Cool? Thumbs up? All right, I'm feeling like most people get it. Cool. Let me look at the notes here, make sure I'm not skipping anything. Cool. This is the basic concept. I just want to let's do a couple more examples just to enforce a couple of things. The one last thing I want to point out is, so these are instance variables, right? So self.name for person 1 is different than 1 for person 2 and person 3. There's also a concept of class variables. And these are variables that get shared among all the instances, right? And we can update them too. So what I can do is I can, if I want a class variable, I define it outside, just kind of outside up here. It's usually like right below class. And I can say like number of employees. If I was, let's say I'm using my persons, and I'm just going to set it to 0. But then every time I call init, every time I make a new employee, I'll just plus equals 1. Number of employees plus equals 1. Do I have to do class dot? I can't remember. I'm pretty sure this works. I always get super confused. Why does it hate it? I always get confused about this. Oh, I know what I have to do. I have to do person dot. So I'm saying in my person class, that's referring to the entire class, right? Not just an instance of it, the entire class. There's a variable called number of employees I want to plus equals 1. So then at the very bottom here, I can do person one dot number of employees. So person 1, person 2, person 3 will all have access to this. I'm not printing it. Three. So I called it on person 1, but I could have called it on person 2 or person 3, right? So all 3 of these instances will share this, but they will not share name or admin. Those are specific to the instance. Cool. So those are class variables. Sometimes you need them and sometimes you don't, but just so you know, they're there. Cool. Let's see. There was one other thing I wanted to go over. Yeah, I just want to write let's write one more example of a function here. So like, oh yeah,
you did self instead of the number of employees. Would that just not? Would that plus 1 then that? It would just be 1 for each other.
Yeah, it would. I think what it would do, it might even error out because it might say that number of them. Because what it's going to say is like it's going to expect there on the instance there to be a variable called number of employees, and you can't. I don't think you could plus equals a variable that doesn't exist. This won't exist. So let's see what. Yeah, let's run it. Oh, it does.
Yeah, because
It'll give 1 for each.
Python initializes to falsy being 0 in this case, and then you plus equals 1.
But it'll see how it equals 1 because it's specific now to person 1.
For every instance.
Yes. Every instance will have a number of employees that equals 1. That can do. And so this idea of like calling on the class, that's what we're doing right here. Basically, when I do person parentheses, oops, what I'm really doing is saying like person run your init function, right? If I don't define an init, then it runs its own, it has its like own already built in, it basically does nothing. But if I overwrite it, then it's like saying person run your init function, basically. Cool. Other questions? So let me take a look at what your challenges are for today.
What if we
Go ahead.
try to overwrite the class variable to an instance? Like before you run person 1 dot number of employees, before you did say person dot 1 number of employees equals 5. Not in there, in the outside. Right before you print it.
Yeah, they have public
Would it change, and then it just changes it to that one player?
If I do this, person.number of employees.
Say, actually do person two number.
Oh yeah, they all share it.
So if you change it for one, it changes for all of them outside.
Oh, the person variable? Oh, sorry, the number, yeah, that'll be overrated.
No, it didn't work.
So it changes it for just the instance.
Oh, that's a good question.
No,
So
I'm
you're
printing
saying the
number of
class
employees.
variable-
Oh, that's right. You modify one, it kind of becomes.
Could you change 1 and 2 and see what happened on the last print statement?
Yeah, change, print, or add another one. Say person.
I got you. Yep.
Wait, what are y'all trying to do?
I don't know. I barely know.
We're trying to see if they can
Yeah,
write
Yeah.
All right.
Turn it into an instance variable.
instead of a constant, they're switching out the key name in it right there,
Okay, person two.
the value.
If you do it as person dot.
So are you guys just changing the type, like from an integer to a string?
We were. Hold on one second. I'm gonna come back to that. I just want to go over this real quick. All right. Don't really. You don't really need to worry about that for right now. That was just like some experimenting. Okay. So your challenges for today are a guessing game, Boggle and Boggle 2. Boggle 2 is very hard. That's all I'll say. You do not have to pair today, but it's optional if you want to do it. Cool? All right, go for it.